Okay, last day of review for the people I need to record for. This is 28 to the end. Okay. So starting number 28. This is the top side of the one of the second to last pages. Write an equation of a line perpendicular. Did we talk about parallel perpendicular yesterday?
No.
Kind of yesterday, not. Parallel. What's true about parallel lines? Other than the fact that they never touch each other.
Same slope.
They have the same slope. Same slope. We've probably written that down before, but I'm going to write it down again. Perpendicular means they have slopes that are negative reciprocal. Negative reciprocal slope. Okay, so they give me an original line. They give me this guy. And they want me to find a perpendicular line. Okay, so I look at the slope. What's the slope of that line?
1/3.
1/3. Okay, so what does the slope of my line need to be?
1/3.
Negative.
Well, if it was 1/3, it would be parallel.
Negative reciprocal.
It needs to be
negative 3.
It needs to be negative 3. Okay, x plus what?
Minus 2. Wait. Plus 2. Plus -1. Plus 6.
Plus b. You do not ever use the 2, 2, 2. The only thing that original equation is good for is the slope. He is going to have an altogether different y-intercept. Okay, and how do I find the y-intercept?
You plug in -1.
You plug in the -1, 6. Okay, so make sure you're plugging 6 into y and -1 into x, and not the other way around, even though they appear first and second, right? Okay, multiply, -3, -1 makes +3, subtract the 3. B is 3. So, right? Subtract the 3 to the other side. Y is equal to, write our equation.
3x plus 3.
-3x plus 3. Yep, -3x plus 3. There he is. Okay? So there is that. Okay? B equals 3. Yep. So there's that. If I would have, and it's fair game, I might ask for parallel on the test. I don't know. If I would ask for parallel, make sure you just leave it the same slope, right? Okay?
If you leave it the same slope, you don't change it to a negative.
No. It would just stay 1/3. Yep, you betcha. Okay?
It's a little dumb sometimes.
All right. 29. Find the relationship or find the value of x so that A is parallel to B. Okay, they label these two angles that we have, and they want us to solve for x, and both of them involve an x, but what do those two things have in relationship to? There's only two options. Only two options ever. They are either equal to each other or they add up together to make 180 degrees. That's the only two options. You have a 50-50 shot, right? Are they equal to each other?
Yes.
Yes. Why? What types of angles are those?
Alternate exterior.
Alternate exterior. And any alternate exterior angles, alternate interior angles, all of them are equal to each other. So we just set them equal. 9x minus 44 equals 6x plus 10. And then we solve. Let's, I don't know, subtract the 6x. I need to get a new green marker. Plus 44. Can I do that at the same time?
3x, yeah, 50.
3x equals 54. Divide by 3. X equals, can you do that in your head? 54 divided by 3.
18.
Did you do it in your head?
18. Yes.
You did?
It's 18.
It is 18.
I don't
You're
have
right.
a calculator, I promise.
Nice, nice. 5 divided by 3 is 1, with 2 left over, which is 24. 24 divided by 3 is 8. So 18. Yep. Try to do those in your head if you can. That just provides you more of a mental check when you go to do like the ACT or something like that, you know? Okay?
You get a calculator.
Yes, I know, but like supposing I type a number in wrong on my calculator and I'm not mentally checking myself, I get the answer wrong. Because they will provide answers on the ACT that are really good wrong answers. So they will know that you might possibly flip two numbers around on your calculator, and they will provide that as an answer. That's mean.
So
Yeah.
if they're alternate,
There is someone's job, like someone sits at a desk and it is their job to provide really good wrong answers. I had to make like a multiple choice test for, I think, the geometry final, and I had to like sit there and try to come up with really good wrong answers. Like, okay, how could a student do this wrong? And then I would list that as the answer. So there you go.
I'm just kidding.
How about
Wait,
Anyway,
so if
so-
they're
there's that.
alternate or interior?
How about give us the
Alternate exterior, alternate interior, they're going to be equal to each
So
other.
what if they're not? What if they're pretty?
What?
I feel like
Well, then they're one of the other angle pairs. They might be like corresponding, right? Corresponding angles are going to be the same. It just depends on what they are. But if it's alternate exterior, alternate interior, they're equal to each other. Otherwise, it just kind of depends on what the other pair is, okay? Now, chapter 3 is transformations, okay? Taking the point A to A prime. What are we doing?
Going down to,
Nope.
or no, up to.
Nope. Look at the coordinates.
I know what I don't know what
We flipped them, okay? So we flipped them. So Y, X now, but what else? We also did something else.
Made the Y negative.
That made the first one negative, right?
Yeah.
Okay? So the Y negative. So this was what we did. We took these two, we flipped them around, and then the first one became negative. No.
We both
Yes.
do negative.
No.
Wait, keep it more.
Just the.
Yes. Yes, the first one became negative, yes. Okay. So negative YX. What transformation is that? Remember? 90. That was 90-degree rotation. Okay? I'm going to write off to the side over here what the rules are for 180 and 270. Okay? Do you remember what they were? 270 is just the opposite of 90. So it is y negative x. So the second one becomes negative for 270, right? 180 is what? Both what? Both negative, but no flip. No flip, but both negative. So it's just negative x, negative y. Okay, no flip, but both negative, yeah?
Yes.
Yes. Write the new coordinates after it's reflected across the y-axis. So we got to write those rules over here too. Y-axis, x-axis, and let's do y equals x also. That was that 45-degree angle line. Okay, so y-axis, what's the rule for y-axis? These are the ones you should just know. What's y-axis?
X becomes negative.
Just x becomes negative, you don't flip, right? What about x-axis? Same but opposite, y becomes negative. What about y equals x? Just flip them. So yx, no negatives, okay? Those are the rules, all right? So reflect across the y-axis, we're just making the x coordinate negative. So I'm going to write down below here, x prime, parentheses, y prime, parentheses, z prime, parentheses. Okay, there is that. Okay, reflected across the y-axis, the x is becoming negative. So negative 1, 1 is going to become what? Positive 1, 1. Okay, y, negative 1, negative 2. What's that going to become?
So are you just changing your y-axis?
Just flipping across the y-axis. So we're only making the x coordinate negative. 1, negative 2. Okay, z, 3, negative 3. The y or the x becomes negative. Negative 3, negative 3. That's what he becomes. Yeah? Okay, good. Okay, and this next one, 32, is a, what? That's it. They want to know the new coordinates, so we name them x prime, y prime, z prime. I don't know why on 32, evidently I didn't end up changing all my stuff, but it's A, B, and Z, so we'll just call them A, B, and Z. But this one they want us to move 5, negative 4, okay? So what does 5 mean?
Override, right.
To the right 5. This means right 5 and down 4, okay? So I could certainly check this if I wanted to graph it, but I don't want to graph, right? So how do we like make our new A, like A prime? How do we do that?
Add 5 to 0.
Add 5 to 0. So 5 plus 0 is 5, okay? And then I take negative 1 and add a negative 4 to it, which makes him negative 5. There you go. 5, negative 5. B prime? What do you got for that one?
7, negative
7, negative 4, okay? And Z prime, or C prime, whatever.
4, negative
8, negative 7. Is that right? Yes. Okay. So you are just adding those values onto each xy coordinate. Yeah? Okay, let's take the order and the magnitude of rotational symmetry. So we're trying to rotate this guy. Okay, so let's talk about what order meant. Like, what does order mean? Kind of. It's based upon the number of sides. How many? It's like the number of times you can rotate within one full circle in order for him to map back onto himself, right? So how many times can I rotate this, okay? And a lot of times what I will do is I will look at a corner, like starting with this corner. If I rotate him this far, he will now be at this corner and he will be the same shape again, yeah? Okay? If I take him and I rotate him from here to here, he will be now at this corner and he will be the same shape again, yeah? If I rotate him to here, he will be at this corner, he will be the same shape again, same shape again, same shape again. So how many times am I allowed to rotate him in order for that corner to be mapped back onto himself? And you're right, the answer is 6, and it has everything to do with the fact that there are 6 sides of that hexagon. Yeah?
Yeah.
Yeah. Okay. Now, magnitude is the what? It's the number of degrees I must rotate him. The number of degrees that I have to rotate him for one little piece of it. How do you figure that out? Yep, 360 divided by your order. And that's 60 degrees. Degrees. I don't know why I wanted to put percent. Don't put percent in there. I wanted to put percent. Okay, 360 is one full circle. If it's doing it 6 times, then each of those little rotations. So like going from here to here is 60 degrees. Each time. What? I've been doing
60%.
Oh, are you writing 60%? It's because of you, dang it. What?
No, what if you have like a pentagon? You can't rotate 5 times.
Mhm.
Oh, no.
As
the
long
one that's
as
like this, and
as long as it is a regular pentagon. If it is irregular, I cannot do it, right? So like here is a pentagon, right? That's a pentagon. I can rotate this guy from here to here
Okay, but what
to
if it's
here.
like half
Okay.
that?
If it was like, let's say it was like this.
Like the.
Let's say it was like that. Can I rotate him anyway in order to make him the same? Even upside down?
No.
No.
So it wouldn't have
But
any
if it
magnitude.
was
So he would not have an order. He would
Magnitude's
he would have no rotational
I'm
symmetry. Yes.
just trying to say, like, you know, like the rhombus thing was like half of that, and the bottom half of the pentagon, right? Like split the pentagon, and then you put it, and you take the top off, and it's like a rhombus, right?
Yeah.
Like
Yeah.
this.
It's like a
Like
trapezoid.
That's what I meant.
Yeah.
Top.
What's a
What's a rhombus?
Yeah.
Rhombus is
Yeah.
like the.
So like this right here. Okay.
Yeah, that thing. Okay.
Okay. There you go.
Not that.
Yeah, you can't.
What
You
is
can
rotate
you
him?
can rotate it like twice.
You can rotate it 180. Why?
If I rotate 100 degrees,
That means it's on the.
that's what it looks like. 180 degrees.
Oh, match up.
So that's
He's got to match up with himself, right? He's got to be exactly the same as what he was before, right? Like visually exactly.
So
the same.
that what? So it wouldn't be a degree.
So if you have to rotate it 360, everything if you rotate it 360 will be the same, right? But if you have to rotate it 360, that doesn't count. It has no rotational symmetry. It has to hit at some other time before you get to 360.
So what if
Like a person. Does a person have rotational symmetry?
No.
If I flip me upside down, do I look the same as I did before? No, because my feet are in the air, right? So, so I have no rotational symmetry. Even though if you rotate me 360, I'll be back to normal, but I have no rotational symmetry.
So that wouldn't. So
That does not
would
count.
put for it.
What?
No.
So you would say no rotational symmetry.
So, but it would have an order.
No. It doesn't have an order or magnitude if it has no rotational symmetry. Then you just be done and you stop. Okay? All right. So there we go. Triangles and congruence. 34. Find the measure of the sides of the triangle if the vertices are blah, blah, blah. Okay, how do I find the measure of the sides? Measure of the sides. What? Somebody said it. Distance formula. Okay? We've done distance formula. Oh,
Wait, is this
Lily loves this one. Distance formula. Here we go. How many times do I have to do the distance formula? x2 minus x1, y2 minus y1. Okay, how many times do I have to do the distance formula? 3, because of it's a triangle, right? I need all 3 sides, okay? So what is one of the sides? EF is one of the sides, okay? So we're going to find EF. What's another side?
FG.
FG.
And EG.
And EG. Okay, let's talk about classifying a triangle by its sides. Okay? Classifying a triangle by its sides. If 3 sides match up or 3 sides are the same, what is he called? If all 3 sides are the same. What? Equilateral. He is equilateral. Okay? If 2 sides are the same, you remember what he's called? Isosceles. Isosceles. I have to like really think about spelling that. Isosceles. Can you have one side be the same? Not really. So if 0 sides are the same, what's that guy called? No. He has a word. He has a name for him, and he's weird. S. Scalene. Okay, so this is labeling him by his sides, all right? So if we have all 3 sides that are the same distance, then he's going to be an equilateral triangle. So we'll base our information off of our result for our distance formula, okay? Are you ready to go?
Yes.
Yeah? Okay. All right, so I've got my 3 distances. I'm going to go ahead and do this. Just 3 times. Just get him up, get him ready to go. My paper slipped. There we go. All right, so I've got all my little brackety things ready to go. I just plot my numbers in, right?
Yeah.
Okay, the first one I'm doing E to F.
So
E to F. Y2 or X2 minus X1. 1 minus. Yep, 1 plus 3 or 1 minus a negative 3. Okay, and then I have negative 1 minus 3. Right? Not plus 3. Negative 1 minus 3 for the y's. Yes, but you're subtracting. Yeah? Negative 1 minus 3. Okay. All right, so let's solve that one completely out. Here will be 1 plus 3, so that's 4 squared, which is 16. And negative 1 minus 3, that is negative 4. Negative 4 squared is it 16 or is it negative 16?
It's 16.
They're always positive. Okay, otherwise this would be the square root of 0, right? 16 and negative 16, that would be the square root of 0. And there's not 0 distance between those 2 points, right? Okay, so it's the square root of 32. Let's just leave it as that. The square root of 32. I don't know what that is. It's a decimal. 5 point something, right? Okay. All right, let's do the next one. F to G. All right, so Y2, my second X, negative 3 minus 1, and then I have negative 5 minus negative 1. Did I do that right? Okay, which is plus. It'll be plus 1, yeah. Yeah, we'll change it. I just always write it all out. Okay? All right, so negative 3 minus 1 is negative 4 squared. 16. Negative 5 plus 1. Oh, boy. So square root of 32. So it is not which one of these? It is not scalene. You know he's at least isosceles, right? 2 of the sides are matching. He's at least going to be isosceles and he's not scalene, okay? What's up?
So when you're like on, let's see, the F and it's 1 plus 3, if it's a positive, can we say negative? Like, can we subtraction and then when it's a negative, you can
Basically, yes. Yes. Okay. All right, so EG, last one. Negative 3 minus negative 3. Did I do that right? E to G, negative 3 minus a negative 3. Okay, then negative 5 minus 3. Yeah? I don't think this guy is going to be equilateral. I don't think so. Plus, negative 3 plus 3 is 0. 0 squared is still 0. Okay? Negative 5 minus 3, negative 8 squared is 64, which is the square root of 64, and that comes out nicely. We can reduce that to be 8. So I have one side that's 8, one side that's the square root of 32, and another side that's the square root of 32. So he is isosceles. So we'll put that down here at the bottom. That's He is isosceles. Okay, there he is. What?
You just do it all right,
There's not really a way of checking it other than graphing it if you want to just graph it and look at it. But I never trust my graphs anyway.
You just do it right.
Just do it right the first time, yeah.
I'm always made graph.
Okay?
I love graph.
You like graphing? Okay.
At least just weird.
Silly girls. All right, 35. Angle 3. Okay? Now, this is made up of a couple different angles, but they asked for angle 3, and I'm guessing you probably have to find angle 1 and angle 2 in order to find angle 3.
Probably.
Right? Yeah, probably. Okay. All right. Ooh, angle 3 is all the way down over there. We know that the one top corner is 90 degrees, and we know that the one over there is 110. And that's all that we know. We know nothing else.
2 is 100.
No, not necessarily. Okay, so let's try to go from 110. Let's start from 110. Can I figure out what this angle right here is inside of that triangle?
Yes.
What is he?
180 minus 110.
He's going to be 70 degrees. Okay? Ooh, it's kind of fuzzy. There we go. Do you agree 70 degrees? That's a 7. Why is it 70?
Oh, because it's on a straight line, which is 180, and then you take 110 minus. I mean, 180.
Straight line. So 110 and 70 have to add up to be 180. Okay? Now, look at some of the markings that are on that triangle on the left.
Well,
It's side and
those two
side.
sides are the same.
It says these two sides are the same. So, if you look at this as like an isosceles triangle, like this way, right? Isosceles triangle that way. If these two sides are the same, and this bottom angle is 70,
And 180 minus 70, and
It gives you that angle, and then you can do vertical angles, and then you can find angle 3.
okay?
Because 90.
But angle 1, what's angle 1? Angle 1 is going to be 70 degrees also. Do you see how that works? Because these isosceles, those bottom two angles are going to be the same. Does that make sense? These two angles are both going to be 70s.
Why?
Okay, because it's an isosceles triangle. These two sides match, so those two bottom angles have to be the same. Does that make sense? Yeah? It's always got to be that way. Okay, for an isosceles triangle. All right, now can I figure out what this top angle is? Right here.
Yeah.
Okay?
Yeah.
So 70 and 70 make 140.
So 40.
So this guy is going to be 40 degrees.
And then
Okay. And so then this side is going to be
90
40.
plus 40, and then 180 minus what? It's 90 minus 40, actually.
Right.
The other one, 3 is 50.
So angle 3 has to be
Wow.
50.
50. That was really a messy procedure. Angle 3 equals 50 degrees. Do you see why that's 50?
Yeah.
Okay? We have to map it all the way through. So we found the 70. Then both sides have to be 70 because that's an isosceles triangle. Found the third one because they have to add up to 180. Vertical angles all the way across. And then subtracting from 90 really. 90 minus 40 is 50. 50 gives you that one. Yeah?
Yeah.
No, we don't care about 2. Evidently. Oh, that was kind of nice. So angle 3 is 50. Angle 2, we could find it.
No.
Yes,
no,
we should.
no.
We should.
140.
It's 140.
Right? What?
But the other one's 40, so that one has to be 140 because they live on a straight line. No? Okay. This one right here is 40, so that one has to be 140. Right? Okay?
Not even.
It's not going to be 110. If those lines were parallel, then he would be 110. Right? 180 minus 40.
How
Okay.
did you get 50? I went on my post.
Where are you lost?
Oh, we got my missing assignment. Yay!
Alright, where are you lost?
How we got
36.
How we got 50? Did you see how we got 40? Okay, 40, 90. This one has to be 50. You had to add a 200. Okay, next. Alright, identify the congruent triangles. Triangle what? Is congruent to triangle what? And then we'll do the angles. Maybe let's do the angles first. So angle D, angle G, angle F. We're going to match those guys up. So which one goes with D?
A. Just kidding. B.
B. D and B go together. Do you see why?
I have to laugh to do it.
Okay, G goes with
C.
C. And F goes with
A.
A. So If we write those triangles out and I write him out as DGF, he has to go BCA. I don't care what order you go in. Some of you guys might want to go ABC, but if you go ABC, you've got to go FBG, right? In that order, okay? So angles, and then this is our congruent statement. Okay, but then you have to have all the angles as well, okay? So all the angles match up. Sometimes it's easier to do that first and then write out your sides, yeah?
They
Okay.
wanted, that's what they wanted.
Uh-huh, you betcha. That's what they wanted. Okay, I'm going to start kind of booking a little bit faster, all right?
I thought
Because
that.
we got to get done.
Oh, it's going so fast.
Okay?
What's that?
Write fast, because we got to get done. We have 20 minutes left. This is the last thing.
So,
Determine which postulate, if any. Okay, so let's talk about the postulates that we can prove triangles that are congruent. What are they? What am I allowed to use to prove? Okay, SSS, let's start with that. Okay, these are my options. SAS,
not ASA.
ASA, or AAS. Those are the ones that I can use. Not ASS, not AAA, or any other combination of those, right? Those are the 4 options that I have, all right? So am I able to use one of those 4 methods to prove that this top triangle is congruent to the bottom one? You think so?
Yes, you can.
SSS? Okay, so I only have 2 sides, right? But she says the third one is the same as itself. But, right? But here's the problem. Here's the problem. It's saying that this side right here is matching this one.
Side angle side.
And it's saying this side right here is matching that one. You are thinking this. This is what you are thinking. You're thinking this guy matches this guy and this one matches that one.
No.
If that were the case, that would be side, 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 right?
I can't.
But for all I know, okay, I'm going to draw this same scenario, but I'm going to draw him looking like an ice cream cone. For all I know, this could be what that triangle looks like,
But
right?
it doesn't. So it's side angle side.
Okay, so this guy matches that guy, and this one matches that one, right? Just like what this one says, right? It's not saying that any of these match any of the ones down there, right?
Yeah.
So it's side angle side.
What?
Yeah.
The bottom angles are the same, right?
What?
The angles on the bottom.
So it'd be none. I don't know.
If they give me this information, I may as very well draw this triangle or this diagram, and this triangle is not the same. Determine which postulate,
If any.
if any. Those triangles are not congruent at all. We have exhausted all of our options. We've tried side, side, side. We've tried side angle side. We've tried all that other stuff, and it doesn't work because this is a counterexample basically. This is my counterexample to this diagram. I am fulfilling all of the requirements that this guy is labeled as, and he looks like that. And those 2 triangles are not congruent. So that's my counterexample.
Ew.
Not possible.
But it's
Not congruent.
Oh, this is.
Those 2 triangles are not congruent, right? You had a homework sheet at one point in time where you had 3 things you had to label, and it was like side, 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 angle, side, not possible for your 3 options. This is one of the not possible ones. Those triangles are not congruent given the information that we have. If they maybe give me another angle, maybe I can try to prove that, right? But the way that they have the tick marks labeled, that does not work.
so
Next.
Okay.
Fast enough.
Next, I got to move
They
on.
don't give us an angle.
They don't give us any other information besides that. Going off of just the information that they have, those 2 triangles are not congruent.
Okay,
Okay?
next.
All right, chapter 12. This is all probability stuff. Okay? So a spinner has 4 equal sectors numbered 1 through 4. I'm going to draw a quick little guy of what he looks like.
Did you just go through 3?
1, 2, 3, 4. Yeah. Those are have like funny tips. The spinner is spun twice. Spun twice. Make an organized list to represent the sample space. So if I spin it twice, what's one of the options that I could get?
1.
I could get a
4 out of
1 and a 1. Let's start from there. Or I could spin a 1 and then a 2. I could spin a 1 and a 3 or a 1 and a 4. Yeah. Organized list. This is my list. Okay, I'm listing them out.
Next.
Let's say I spin a 2 first. I could spin a 2 and then a 1, or a 2 and then or a 2 and then or a 2 and then There we go. Are there 16 options? Yes. I could spin a 3 first, so 3 and a 1, or a 3 and a 2, or a 3 and a 3, or a 3 and a 4 in that combination. Or I could spin a 4 and a 1, a 4 and a 2, a 4 and a 3, or a 4 and a 4. Does that make sense?
Yeah.
Any one of those combinations if I spin the spinner twice, right? Okay. If I spin the spinner 3 times, that's a lot more options, right? I can spin a 1, 1, 1, or a 1, 1, 2, or a 1, 2, 1, or a 1, 2, 2. I won't give you anything that's really, really large. Like this is probably as large as I give you. But
Oh, there's some.
keep in mind that if you spin the spinner more times, it makes it harder. Okay. All right. Carl is creating greeting cards from a website. He has to choose from 2 types of paper, 5 different fonts, 5 different greetings inside, and 3 types of envelopes. How many different options can he have?
We can figure it out.
How do you do it?
Multiply.
You multiply all the options together. So 2 times 5 times 5 times 3. 2 times 5 times 5 times 3. Did you do that in your head? Good job. 2 times 5 is 10. You're right. 2 times 5 is 10. 5 times 3 is 15. And 10 times 15 is 150. There are 150 different looking greeting cards, okay? Because maybe they have the same fonts, but they might have the different wording, right? Or etc., right? Yes. Okay. What is the probability of the randomly selected permutation? This is where it gets hard. Randomly selected permutation of the letters shown below spell that thing, okay? When I taught this to you, I said, like, Elena's name works for this, right?
Yeah, because I have 1,000 different letters.
Lily works.
Lily works, right?
So what Elena's one?
What's the tricky part? So let's talk about Elena for just a second. A-L-A-Y-N-A. I don't know why I wrote my A's all different, but anyway, whatever. That's all right. Elena. Okay? So if I put Elena's letters into a hat, like the letters of her name, what are the chances that I pull them out exactly spelling Elena, right? Well, if I pull this out, number 1, number 2, number 3, number 4, number 5, number 6, they will spell Elena exactly. But I could go 1, 2, 3, 4, 5, 6. And it would still spell Elena, right? Or I could, right. I could do any combination of those, right? So how do I accommodate that? How many letters are there in her name to start with?
6.
6. So I do 6 factorial.
3 of them are the same.
3 of them are the same. So I do, on the bottom, 3 factorial. Okay? So the formula is,
I almost wrote this down, but it's not the same.
it's not the same one. The formula is n factorial over r1 factorial times r2 factorial times blah, 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 blah. Because sometimes you will have more than one repeating letter and you put all of them under there, right?
Hey, this is kind of like what we did in chemistry.
Yeah, probably. How many letters are there total? In the word permutation. 11 letters. Okay, so 11 factorial is my top number. 11 factorial on the top. On the bottom, how many? What's the first letter that repeats? T.
That's it.
Is T the only one that repeats?
Yeah.
So just 2 factorial on the bottom. Is that the only one that repeats? Okay. Take 11 factorial divided by 2 factorial. And what do we get? Do you guys understand why we have to divide out? Because they will spell the same thing. Okay.
Okay, I tell you.
You would put 3 factorial, yes.
19,950,000.
Okay, hold on. 19,950,000. 58,000. 400. Okay. There are that many ways to pull those letters out of a hat and spell, like, basically non-words. They're not words.
Wait, so the probability
Oh, yes.
Yeah.
What is the probability? So we need to convert that to a probability. So it would be 1 over that. Yep.
Bros.
There's only one word out of 19, almost 20 million that will spell permutation exactly, yeah?
That's like
Okay.
the odds of like a phrase in another word.
Yep. Yep. All right, we've got 5 left.
Wait,
Can we make it?
Wouldn't it be,
We've got 9 minutes and 5 left. Here we go.
wait,
3 of 10. What?
Wouldn't it be 2 because you can switch around the 2?
It's just T's.
Okay. 3 of 10 members of the AV club are randomly chosen to read the morning announcements for the month of May. What is the probability that the 3 freshmen of the club are chosen? 3 of 10 members. We're choosing them.
3 out of 10? Oh, wait. No. 1 out of 10.
How many ways can I choose them? So like there's 10 people in here, so maybe I choose Lily, Elena, and Colton, but then maybe instead I choose Lily, Elena, and Amelia, not Colton. That's like altogether different combinations. It has to do with that, yes, but when you're choosing 3 out of 10, you have 2 different options. It's either a combination or a what? Permutation. Okay, which one does order matter? Permutation is president, vice president, secretary. Order. Order matters. Order, no order. Okay? So, does it matter what order I choose them in, or does it not matter what order I choose them in? Why does it not matter? They're all doing the same job, really. Right? They're all doing the same job. It doesn't say that one is reading something different than the other one. They're all reading the morning announcements. So no order. So we're going to go with that one. Okay. And 10C3 is my combination. Type that in. See what you get. How many ways can I pick these people apart? Because 10 is the total number that I'm choosing. So it's NCR is what it is. N is the total number. R is the number. R is the number that I'm choosing. What is it? Now it's got to focus again. 120. There's 120 different ways that I can choose those students. 3 students out of 10. Yeah? 120? Okay. Now, what is the probability that I choose the freshmen? The 3 freshmen. There's only one group of 3 freshmen. 1 grouping out of 120. Because we're saying that there's 120 different ways to group. Okay? All right, we got to keep going. Find the probability that K is on XP. Okay? So I want him to live here in relationship to the entire line. Okay? I want him to live there. I want him to live along the 7 in relationship to the entire line. But it's not 1/3.
28.
28 is the whole way across, right? So 7 out of 28 is the whole way, which is 1/4. So he has a 1 in 4 chance that that dot is going to live on that line, right? In a circular spinner, the sector colored yellow has a central angle of 85 degrees. How big is 85 degrees? Ish.
Like,
A little less than 1/4, right? There it is, right? Maybe that's 85 degrees, okay? A little less than 90. So 85 degrees. What is the probability that the pointer will land on yellow? So we know that that guy is 85 degrees. But what probability or what proportion is 85 degrees in relationship? It's, if this was 90, it would be like a quarter of the whole circle, right? It would be almost 1/4. No?
85
85 over 360 is what fraction? What? 17 over 72. Okay. That's probably how I will have you leave it. What's that as a decimal, though? Let's just think about this. 0.236, etc., right? That's 23% or 23.6%. Okay. We said if it was 90 degrees exactly, that would be 1/4 of the whole thing, which is 25%. But he's a little less than that, right? Okay. The proportion that we want, what proportion of the circle is that? It's about 1/4. It's a little less than 1/4. Okay? Right? 1/4 would be 90 degrees, so it's a little less than 1/4. Probably 17 over 72. Okay, but I'm just showing you that 23% is a little less than 1/4, which is what we said 90 degrees was, right? Okay? 2 cards are drawn from a standard deck without replacement. Without replacement. Underline that word. What is the probability that the first card is an ace? Okay, let's do that. First card is an ace. How many aces are there? 4 out of 52. That's an ace. Okay? And the second card is a king. How many kings are there? 4 out of, and we're not replacing, so now we only have 51 cards. Okay? Now, I am drawing 2 cards. So am I adding or am I multiplying? You are multiplying. When you're drawing 2, you are multiplying. Okay? So let's reduce this. 4 out of 52 is 1 over 13.
Wait, so if you're not replacing, you're adding? Or if you're replacing, you're adding?
No. If you're replacing, you still add. If you're only drawing 1 card out of 2 categories, that's the next one. That's the next one. I'll show you when we add. Okay? That's the next one. Okay? So even if you are replacing, it's still going to be multiplying because you're still drawing 2 cards. Okay? So 1 times 4 is 4. What's 13 and 51? 663. I don't know.
Yeah.
663? There you go. 4 out of 663 are your chances. Very, very slim that combination would happen. Okay, 45. What is the probability of drawing an ace or a spade? How many cards am I drawing? 1 card equals add. I'll put that up here. 2 cards equals multiply. I'm drawing 2 things. I multiply. I'm drawing 1 thing. I add, okay? An ace or a spade. All right, when I am adding, I always draw a Venn diagram. Ace or a spade is like this thing. Right? That's a spade. Okay? How many aces are there? 4. How many spades are there? 13. Now, can you have an ace and a spade at the same time? Is there a card that is an ace of spades? Yes. So there is 1 card that I need to subtract out because he's considered in both categories, right? Okay? So this is the add and subtract thing, right? Okay? So how do I figure this out? 4 over what? 52, because there's 52 cards, plus 13 over 52, minus 1 out of 52. 4 plus 13 is 17, minus 1 is 16 out of 52. But I think that will reduce. Divide both of them by 4. What's 16 divided by 4? 4. And 52 divided by 4? 13. 4 out of 13. We made it!
So if you had
With like 30 seconds to spare. You would still multiply.
Okay, so if it's
Yep.
above 1.
If it's 2 or more cards, you're going to multiply. Yep, exactly. We made it. That's going to be a long video. Sorry, people.